Hi, I'm making a video on PLC programming. My friend named Bilal Hussain Khan actually challenged me. He said you can't do it. So I'm gonna prove him wrong and I'm gonna make a fucking video. So I basically bought this fucking course on Udemy. It's on AC Drive, VFD, servos, and steppers. So this guy actually shows you, he actually teaches you how to install and program AC drives, which is basically VFD, variable frequency drives and servo drives in any control system. So basically you gotta know what is AC drives. So AC drives are used to control the speed, operation, torque, and direction of motor. And basically the VFD he uses is Allen Bradley Powerflex 4M. And so basically I'm gonna take you, so if you go on Allen Bradley website, Rockwell Automation website, and go on product and drives and motors, and if you go on AC low voltage, um, and scroll all the way down to 4M, compact drive, you'll see that this is the one he uses. It's a low voltage drive, and you can pretty much read through this website what it does and stuff of that nature. I'm gonna go to his course content, understanding VFDs and startup parameters. Under, Understanding VFDs, variable frequency drive. um, I'm gonna let this motherfucker explain to y'all.
I'm going to use explain. This is a video demonstration. That's the drive. That's how a VFD looks like. Okay. That's the three-phase induction motor, which is connected to the
This
drive
is the
using this wire over
VFD.
there. This is the keypad
It
display,
is connected
and
to the
that's the input
motor.
power supply which I'm giving to the drive, which is 220 volts single phase. Okay, that's the frequency display as of now. This is how our drive setup look like. You can see here L1, L2, L3, because in some countries we have 230 volt pads on this coil. So what happens when you press this A? This will be that says VFD status screens. We have different, so which is here. You can do that output feedback now.
Basically, this is
You know,
the
these can be used to
VFD. That's all you gotta know. You don't need to know right
feedback
now
number.
all the shit is. This is the wide thing is VFD, that's all. He just bullshits too much actually. This is the VFD diagram. VFD connection with PLC. He was actually going through this diagram. This is the VLC. It has inputs and PLC output terminals. Blah blah blah. Selecting the source of frequency in VFD, selecting the source of operation in VFDs.
But this to explain, reading in forward direction. If I turn this off, motor will stop. This will turn the motor in reverse direction. That's the source of
Actually, I'm
operation.
gonna go to the second part of this tutorial, and it's on source of frequency in VFD.
And by digital keypad. This means frequency can be determined by this keypad. This switches. This is increment, this is decrement. A little bit damage here, but anyways, that's a increment and that's a decrement. We can control the frequency by pressing the switches. Second phase, master frequency
I'm
determined by
grabbing
0
the
to 10 volt
switches.
on AVI terminal. Okay, so AVI terminal is over here. So by supplying voltage of 0 to 10 volt, we can control the speed. Third phase, frequency determined by the parameter. Notice the frequency. It's time to open. This voltage is
Actually,
time to go
this
to the
is
area and the
he's
ground. Okay,
using
so that's the PLC. Go to here.
Delta
Select my PLC pieces.
software.
Press OK. Alright. So, okay. Anyways, so very quickly I'll go to my analog card module. My card is D2A, which is connected to slot 2. Okay. And this explanation of card is already there in the course, PLC course, you can find out there. Is 0,
What the
voltage is 0 volt, frequency is 0
software
hertz.
is
If bits are
using,
1000, voltage is 0 volt, so
motherfucker?
frequency is 0 hertz. So if I change that, if I put the value, do is we just have same bits, we can find this potentiometer. Frequency can be increased and volts. Third one was AC also work. Okay. Now these terminals You see the
This is
diagram.
the
These
source
are your
of
input to
operation
N5.
in
So
VFD.
external terminal says this is achieved
I have no
so that you
idea
can
what that
see the
is.
direction. Okay. Take okay.
Basically, this is an advanced level course because you gotta know how to program the PLCs. Uh, Auxiliary parameters in VFDs, acceleration and deceleration, internal PLC mode in VFD, other special parameters, VFD feedback signal, biasing, VFD support document and supplementary material. Oh yeah, so this is the Alan Bradley 4M video tutorial, understanding the VFD Powerflex 4M.
Let's go step by step what we have in this course. In this first video, we'll understand the various components of this drive and the wiring as well. Alright. So if you see this drive, correlated with the motor capacity. Alright. If you're driving a motor having a reading of 0.5, safe. Alright, that's the specific frequency which we are using. Alright. So not on. So the motor is blinking, it's getting off. So that's the reverse direction. If I press it again, it will toggle that direction and move to the forward. So motor will first go to 0, then it will move to forward. That's the forward direction. Then you have this parameter to say, this will show you light. Alright. What we have inside, so if I by which you can control the drive by modulus applications using a PLC. Okay, by these three plugs here. So we also have a motor, three-phase motor, which can be connected to these three terminals. All right, wiring. So we'll discuss more about internal wiring. What are the different control terminals? On the relays. And relays are wired in such a way that if you turn on the relay, these control terminals will be activated. How this is activated? What do I mean by activated? By further lessons, we need to understand this diagram as well. And also see here as well. This is the IGN through R3. That's my 90. Okay, which is 24 volts. In source mode, we have connected 11 number directly to one number. This is for stop via one relay will be off. And then you can start and stop the drive using these terminals. Using the terminals, which you can see here, yeah, the start run. What is the position of drive? The drive will get. To control the motor using your keypad, which will decide what should be the start switch. My motor started using the switch. Right now, motors are.
So basically, he just bullshit his way through the Alan Bradley VFD, which is Powerflex 4M, and after that point, he. So in your interview, you can just say that you just played around with Powerflex 4M AC drives, and you did some PLC programming. You don't need to go through all this bullshit, because the time is limited. Introduction to servos, motors, and drives.
That we need to include some control. So, logic behind changing the direction of motor is if you interchange any two terminals, any two power terminals. And we're going to see.
So the servo drive he uses is Delta B series. Introduction to servo drive and motor.
But I'll just go through the previous list. To see our videos and our tutorials in which we see how to work on servo drives, how to create different circuits, and how to control the servo using PLCs and other interfacing circuits. Alright. So to start with, I'll just go through the previous list about the basic motor
So
control circuits.
basically, the
So let's say if you want to
PLC
control the motor, what
gives
you're going to do is
instructions
just take the power
to
source. And
the
we're talking about three phase. For instance, if we see
servo
the circuit,
drive,
this is the
and the
motor.
servo
This is
drive
three phase L1, L2,
rotates the
L3
motor.
connected to three
That's how
control.
it works.
So we installed a contactor in between the power for forward, CR, CR, and CR for reverse. Now in this case, the logic behind changing the direction of motor is if you want to reverse the circuit that controls the direction. We have done using VFD, okay, in which the control signal was also controlled using VFD. Now there is an angle motor with an encoder to control the driver. Now that also depends on the nature of driving. Sometimes from this wire. Then you have one more connector here. This is for programming. So this goes to a lab. Now this is the driver. Sure, your deals should have transistor type outputs. This is having high speed control, then relay type. Generally, we have relay type. Okay? So the architecture is servo driver needs a PLC if you're controlling position control. Now there are other modes as well. There's a velocity mode in which you can give 0 to 10 volt signal or 4 to 20 milliamperes. And there's a torque mode for which you also need 0 to 10 or 4 to 20 milliamperes to control the driver. Now that also depends on the nature of driving. Sometimes it only accepts 0 to 10 volts. Some drivers also have 4 to 20 milliamperes signal to control the speed. right? So that depends. But 0 to 10 volt is by default available in all servos. That was the servo position control mode, little item order. Now, this is the system configuration. How does the driver look like and how you have to connect different things together. So for that, let me just enlarge it. Now, this is the driver. I'll show you that in the camera as well. This is the driver. This is getting a supply from the main. This is a power source. Single phase 220 to 230 volts. This is 1.5 kilowatt, one phase to 3 phase. So it can accept single phase if it is 220 or 230, and it can also accept 3 phase if it is in this range, 230 volts. It can accept both. So the connector is connected here just to start and stop the power for this servo drive. Alright. Now you have a connector here. This is CN1. This is 25 pin connector. This is analogous to M0 to M5 terminals in Vfd. Now this connector is used to control the servo for different operations like position, velocity, and speed. We have to give signal to these pins. We understand that in more details later on. Then we have CN2. This is the feedback coming from the servo drive, servo motor. This is the encoder at the back. This is giving the feedback by this connector to servo driver. So driver can read the speed and RPM feedback, position feedback from this wire. Then you have one more connector here. This is for programming. So this goes to a laptop and a dedicated programming device. So this terminal here is used to program the servo motor because we do not have any buttons on the top to change the parameters, to enter the parameters. So we have to do that using a PC or laptop. Going to use this hole to this hole. If you need 45 degree or 90 degree, you can do that. So this is called indexing. Typical indexing video, and you can do that using some push. What is having? Okay. Good. How to control that. So when servo is ready, you need the feedback, or when servo is on, you need the feedback.
3-phase motor circuit using contactor. Velocity control mode in servos, understanding wiring and programming, running servos in forward reverse by 0 to 10 VDC, circuit diagrams for forward reverse 1, analog scaling and velocity control mode, internal velocity control mode in servos. I don't think so I'm gonna go through all of them. Indexing of servos 45 degrees with time delays.
Now for 45 degree, how many pulses are required? For 1 degree, 20 pulses. For 45 degree, multiply by 20, 900 pulses. So first you have to 2 seconds, because time basis, get in. 45 degree, 2 second delay to activate the servo. So let's try and downloading this logic in the PLC and let's give it a start. So this will be okay to put here. Run, PLC at stop. 45 degree, 2 second delay.
Remember the name of the software is Delta WPL Soft. So just make sure go over enough for your interview for you to tell in your interview what you did. You know what I'm saying, that servo torque control mode, digital output signal in servos, digital input auxiliary signals, AC drive wrap up. So basically, I am just gonna go through the let's go through each of them quickly. So this is the circuit diagram, we have gone through it. Let's go through velocity control mode, circuit for forward.
Okay. So let's say we have these 2 switches here. These 2 and 9. That of this stop 5 volt is 1500 and 10 volt is 3000, which is enough. So your circuit is complete, and I press the other switch.
This is easy. Forward and reverse, analog scaling, and velocity.
Very, but still, and directly put 1000 here, and your scaling becomes from 0 volt, 0 speed, but motor. Parameter can change the scale of your motor. Want to attain at 10 volt. That is what this parameter is. Alright, thank you.
Understanding acceleration and deceleration time.
Time, the servo motor. Now you might have know.
It's the time taken by drive to reach rated speed from zero rotational speed. Um, servo position control mode via high-speed PLC output. Understanding the wiring and holy shit, bro.
And do that sign comment again. Okay. And you have to make sure your Y2 should be connected. Common of that output must be connected to the 30 number. If I degree with 2 is gate 20. So you can see that it's just running at
Indexing of servo at 45 degree, indexing of servo at 45 degree using sensors.
how to use the sensor. So similarly, pulses for indexing for 45 degree will be 900 pulses. We load the libraries. So I'm using a proximity sensor, same as P2. So my proximity sensor is generally NPN type. So if you know the NPN type, it gives you a 0 sensor. It generally is in the wiring here. A4 volt, 0 volt, and one is NPN output. Drop here. And SEX0, that is the rising edge coming from my sensor. It's going to set my M0. Set. Index is 45 degree, and I do not need these timing loops. So when index is completed, it is going to reset my M0. So with another pulse, it will, okay, so when I actuate this one, I'll go again. And sensor gets on in the servo. If you're running doubt, give me a comment. I'll get back to you. Thank you.
Like, fuck, bro. It's understanding torque control mode using 0 to 10.
We have to maintain a, in this case 1.27 as if I reduce the parameter number, okay, and if you want to control the speed of motor in the torque command, you can use this parameter, which is set.
Yo, I'm just gonna say in my interview that I did one project with the senior engineer, and I can't do much,
Okay.
bro. Like,
See,
I
you can
know
use
how
this
to
as
do
internal
it, but
mode,
you know,
10%,
I can
just to show
figure
it
it
goes in.
out. But I only did one project. Fuck it, bro.